Stan Gibilisco here. I'm going to show you the difference between a sine wave and a cosine wave. Shape-wise, there's actually no difference at all. What you see here is a graph of the trigonometric sine function for values of minus 3 pi radians to plus 3 pi radians. The radian is 180 degrees of phase, so that's 180, 360, 540 from minus 540 degrees to plus 540 degrees. Here you see the cosine function graphed over the same interval. Notice the peak values are 1 and minus 1. This is a straightforward sine function. The angle theta and the cosine of that angle, or the angle theta and the sine of that angle. The wave shapes are identical. A sine wave looks exactly like a cosine wave, but there's one important difference. Notice that the cosine wave is shifted in phase by a quarter of a cycle to the left. That would be earlier in time. You can think of this as a time axis, the past going to the left, the future going to the right. The cosine function reaches its peak right at 0 time, as we mark it here. The sine function reaches its peak exactly 90 degrees of phase later, so it has a 0 amplitude positive going at the 0 point. The cosine has a positive amplitude of 1 at the 0 point, and it crosses the 0 point pi over 2 radians, or 90 degrees of phase, earlier in time. So a cosine wave is nothing more than a phase-shifted sine wave. Otherwise, they're exactly the same thing, and you can pretty much use the terms interchangeably if your intent is to be general in your definitions. Mathematically, the cosine is the derivative of the sine wave, or the cosine function is the derivative of the sine function. That is to say, the cosine is the rate of change of the sine function. So the sine function reaches a maximum rate of change in the positive direction, maximum increasing, say, at 0. That's reflected by the maximum value of the cosine function at that same point. As another example, we offer my call sign, W1GV, ham radio call sign. Just a little glitch there, but the sine function reaches a maximum and has a 0 rate of change at plus 90 degrees of phase and minus 90 degrees of phase. That 0 rate of change is represented by these 0 points here. So when you hear about a sine wave versus a cosine wave in electronics, the only difference is that a cosine wave is shifted 90 degrees earlier in time. That's 90 degrees of phase, or pi over 2 radians, 90 degrees earlier in time than the sine wave, which is 90 degrees later in time than the cosine wave. We sometimes say the cosine wave leads the sine wave by 90 degrees, or the sine wave lags behind the cosine wave by 90 degrees. Otherwise, shape-wise, you can multiply the amplitude by a constant or the time interval by a constant and get a wave that has a different period or a different amplitude, but the essential wave shape is always the same for both types of wave. Stan Gibilisco signing off. Until next time, so long.